In the previous two sessions, we have learned the arrangement and subsets. Let's now see how these are implemented in the real-time problems. So we take first example, a company has 10 security shifts available and there are 22 applicants. How many ways the manager hire applicants for the 10 different positions? Please note the word here, 10 different positions, right? And these are different. So this is a arrangement problem. So we draw again the 10 blocks, 4, 5, 6, 7, 8, 9, 10. So there are 22 applicants. So 22, then one applicant is gone because one position is filled. Then there are 21 ways, 20 ways, 19 ways, 18 ways, 17 ways, 16 ways, 14 ways, 14 ways, and 13 ways. So this is nothing but, you can say in the more complex format is 2250, which is nothing but multiplication of all these numbers, as we know from the permutation law. So we are going to permutate here, not the combination, because we have to fill the 10 different positions. So let's take an example, a similar kind of example, but with a slightly different meaning, right? So let's see what we have got in the next. Okay, so JEE is we have this one. Okay, so we have this problem now. You can see here the JEE is hiring 12 zookeepers. There are 300 applicants. How many ways to hire 12 zookeepers for the applicants? You see all the zookeepers are same, right? These are not the different positions. So what you can do is that first arrange these 12 zookeepers, to arrange these 300 applicants into 12 zookeepers places. So that can be done via 300p12. And then since all the 12 zookeepers can be arranged themselves in 12 factorial ways, so that is nothing but 300 C12. I leave up to you to calculate all these numbers. I'm just trying to give you an example and try to make you understand where to use combination and where to use the permutation or arrangement, right? Now let's try to look at few of the more complex examples now, which could require more knowledge of different things. Okay, so let's start with this one. So okay, sorry. So we have this one, this problem, which states that find the number of integers between 3000 and 6000 in which no digit is repeated. So as we have seen that this is a clear-cut case of arrangement, right? So now to do the arrangement, we will use the basic multiplication principle. So we have 4-digit numbers because this number is between 3 digit and 3000 and 4000, 6000. So these are like 4-digit numbers, among which the first place can be filled only by 3 ways, either 3, 4, or 5. So it can be series of 3000, 4000, or 5000, because it is not greater than 6000. So it can be filled via 3 ways. Since one number is filled and we have 10 numbers from 0, 1 to 0, 1, 2, 3, 3, and so forth till 9. So one place is filled here, 3. So this can be filled via 9 places. The next one can be filled via 7 and 8 and 7. Since because the numbers, the digits are not repeated. So the final answer will be 3 into 9 into 8 into 7. That is, again, if you want to see it into the P format, so it is nothing but 9P3, right? The second case here is a little bit tricky. So let's try to solve that. So the second case here is a little bit trickier one. Yes. So let's see what the second one says. The integers are even, right? So the integers will be even only when the last digit will be even, right? So the last digit can be filled via 2, 0, 2, 4, 6, and 8, right? So we again build this block and try to use the multiplication principle here. Now this could be even. So this can be max filled by 5 ways. But please note, we have to break this into 2 parts. The first digit could be even or odd, right? So let's try to break it into 2 cases. So case 1A, that first digit is 4, and then we put or there because so we can fill the first place by a this way by many ways, and or the first digit is 3 comma 5, either of these two, right? So let's try to use our multiplication principle again. So we take the exam case A first. So the first digit is 4, so that can be filled only, okay, we will do it like this. So this is 4, so this can be filled only by one base. Now one of the even number is gone because the even numbers cannot be repeated, right? You know that, right? So the last digit, since 4 is gone, so we have only 4 places, 4 ways in which we can fill this. Again, 2 digits are gone, so we are left with 8 and 7. So the total number of days will be 8 into 7 into 4, right? And we will take the case B now. Case B. So case B here, the first digit could be filled by a 3 and 5, so it can be done by a 2 ways. So again, we write it like this. So the final 4 digit, since these two are odd numbers, right? So we are left with the 5 places here. All the 5 can come here. This is filled, can be filled by a 5 base. Again, the 2 numbers are filled. So let's say here is 2 and here is 3. So we are left with the 8 numbers, and the next one will be with the 7 numbers. So that will be again 8 into 7 into 10, which is equivalent to, we are using OR here because see, these two are disjoint sets, right? So by addition principle, simply we can add these two to get our final conclusion, which will be 14 into 8 into 7, and we see that it is nothing but 14 into 8p2, right? Because we are multiplying it 2 times and reducing it one by one. So this is a slightly complex problem which we have used. Now let's try to move into slightly more complex problems. Okay, now let's look at this problem. Okay, so we have this problem which states find the number of 6-digit binary sequence containing exactly 2 zeros. So the binary sequence comprises of only 0 and 1. So we have given example like 0 0 1 1 2 2 1 0 1 1 0 1. Now if you pay close attention here, ordering is not important among these 6 places, because 0 0, and if we say it is 0 2 and 0 1, and if we place the same 2 zeros there, so if we place 0 2 and 0 1, it's the same thing because 0 0 is one sequence which will form. So here the ordering is not important. So clearly it will break into the combinatorics problem, right? So the combinatorics problem suggests that we need to choose 2 zeros from 6 places, right? So that is equivalent to saying 6 into, which is again 6 into 5 divided by factorial 2, which is 2 into 1, that is 15. Right? So you can clearly understand that you have to choose among these 6 places 2 zeros, you can place it. So you can also try to choose 2 zeros from 1 2 3 4 5 6. So you can choose 1 2 as one place, you can simply enumerate that, then you 1 3 1 4, then 1 5, then you can do 2 3 2 4 2 5, oh sorry, 1 6 here again, 2 5 and 2 6. Then you can do 3 4 3 5 3 6 here, and then you can have 4 5 and 4 6 here, and then 5 6. So if you count all these things, that will come down to 15, right? So this is our answer. Now let's try to check another problem. Is at a conference of a science, there are 19 participants from the mathematics, physics and chemistry. Among them 9 are from mathematics. How many ways we can have a 7-member committee be formed from these participants, in which each of the following cases there is no restrictions. Okay, so as we have noted earlier that if there is a word committee, so that means the ordering here is not important, right? And since there are no restrictions applied, so that could be easily said into, so we have to form a 7-member committee out of 19 participants, so that will be nothing but So this is problem number 1, first part, C7, right? So that is again 19 into 18 into, you have to write it 6 times if you want to calculate it, right? But I'll leave the calculation 1, 2, 3, 4, 5, 6 and 12, and then you have to divide it from the 7 factorial, or you can simply just write it like this, right? So it's up to you to calculate this number and see what is the result. So this is 19C7. There is no one from mathematics in the committee. Since there are 9 members from mathematics, and if there is no one from the committee in mathematics, so how many participants are left, right? So we have total is 19 participants. We go attempt the problem number 2. So we have 19 participants and 9 are from mathematics, and there is a restriction that no one should be from the mathematics. So we are left only with the 10 participants, and we have to form a committee of 7. So that will be 10C7 will be equivalent to 10C3 as we have seen. So that will be 10 into 9 into 8 divided by 3 into 2 into 1, right? Now the third question again is a kind of a similar thing. So it says, third one says the committee consists of participants from mathematics only. So how many members we have to choose from? So we have 9 people from mathematics, and we have to form a 7-member committee. So that again is 9C7, which is equivalent to 9C2, that is 9 into 8 divided by 2 into 1, right? Now let's take an let's look at the fourth one, which is slightly complex, but we will see. There is exactly 1 from mathematics. So first you have to divide. There are 10 who are not in mathematics, and there are 9 who are in mathematics. This is M, let's say M, and this is not mathematics, so not NM, right? Now we have to choose exactly 1 from mathematics, right? Exactly 1. So 1 should be chosen from here and 6 from this set, right? So, and since 1 should be chosen from here and 6 from this, so again when we use the word and, normally in our counting principle it is nothing but multiplication. So this can be done via 9C1 into, right? So there are 2 places to be filled. Let's see, let's not go with the and thing. Yeah, so let's try to see that there are 2 places to be filled, 1 from this segment and 1 from this segment. Then this can be chosen into 9C1 way, and this can be chosen into 10C6 ways. So these 2 places are filled now. So this is the multiplication by multiplication law. So it is again 10C4, which is 10 into 9 into 8 into 7 divided by 24, which is factorial 4, and into 9, which is 9C1, right? So we get the final answer as this. Now let's look at the fifth one, right? It is slightly more complex, and so it says there is at least 1 from mathematics in the committee. Now how we are going to do that, right? So it says there are at least 1 from mathematics. So we have various options. So we have 1 from mathematics, we can have 2 from mathematics, 3 from mathematics, 4 from mathematics, 5 from mathematics, 6 from mathematics, and all 7 from the mathematics, right? So this is the all the possibilities. So these are all 1 from mathematics or 2 for mathematics, 3 for mathematics, and you clearly see that these are disjoint sets. So by the addition principle we have to find there is 1 from mathematics and add it with a exactly 2 from mathematics, exactly 3 from mathematics, exactly 4 from mathematics, and 5, 6, 7 henceforth. So you will see by the same logic here, the 1 from mathematics will be this one, right? So that will be 10C6 into 9C1, or we can see 2 from mathematics, so we can choose from mathematics, and from the rest 10 we have to choose 5, right? So you do the mathematics, all this, and all the 7 from the mathematics will be nothing but 9C7 into 10C0, which is again 1, right? Because there is no, that is always an empty set as a subset, right? So that is 1. So you have to add all this, but there is a better way of handling this problem, and please keep a note. It's very crucial when there is a word at least, right? So what you can look into from our state theory, we have learned the complement rule, what the complement rule says. So we have to find there is at least, so we have to find here that there is at least one from mathematics. So what we can do is that we find all the combinations which we have done it earlier as 19C7 and subtract the subset which is none from mathematics. So if there is none from mathematics, so this is the only possibilities which are left here is that 0 from mathematics, which is no one from mathematics, right? That makes it complete set. 0, 1, 2, 3, 4, 5, 6, 7. That is the only way you can count. So we find 0 from mathematics, so 0 from M and 7 from, let's say, not mathematics, right? So that can be done via 10 participants are late, and this is the answer. And I leave up to you to calculate and verify that this and this will be the same. So these two will give you the same result. But it will be easier for you to compute it like this rather than adding all this multiplication. Here you can do it quite easily, same as both. So here we are using the principle called complement principle, right? Principle with MP, multiplication principle for finding these combinations, and then simply using this, right? So this is one of the problems which we have done. Now let's try to look at another problem that will be, okay. Now again, this looks quite difficult, huh? So if you are aware about the TikTok game, so if you are not aware, let me show you how the TikTok game is played. The TikTok game is played from our childhood. So we draw this, right? And somebody starts with the cross, and then somebody puts 0 here. Then the first player will put a cross, then somebody will put 0 here. And so it says it should end in the 5th turn. So this is 1, 2, 3, 4. Now the cross is there. So if it needs to end, then the cross part needs to win this, right? So if somebody, so how the cross part will win here, right? By putting 3 crosses. So so that is here. So I put X here and you put this, and then I win because I cross this, right? I cut this part. So I am win because I have winning sequence here for the triple X. And since it should happen in 5 turns only, there will be 3 X's with such combination. So let's see how many ways this 3X will win, right? So there are only 8 ways in which this can win, all in the same row, right? So these are 3 ways, or you can say all in the same column, right? So I start with here, I start with here, I start with here, I start with here, and I put here, right? And then the diagonal, 2 diagonals. So either this, or this, and this. There are total number of ways in which the cross will win is 8, right? So we have 8 ways of winning. So if it needs to end, then somebody needs to win, and X can only win, the cross can only win because it is 5 turns. So the cross has 3 chance to move, and zeros have only 2 places to move, right? So there are 8 ways for this cross to win. Now, if you look at pay close attention, again here, let's say the winning combination of cross is this, right? So this cross, we can start from here, we can start from here, so we can start from here. So this is kind of an arrangement of 3 numbers into 3 places, right? So this can be done via 3 into 2 into 1, that is 6 ways, right? Because this is clear cut, 3 spaces are there and you have to arrange that. So first place can be filled by 3 ways. So we are now left with the 2 ways here, 2 ways and 1 way, because this is just the arrangement of it. Now, if this is the case, then how many places are left? So we are left with 1, 2, 3, 4, 5, 6, and we have to put two zeros, right? So it is similar to saying how many ways 2 zeros can be filled among 6 places. So that can be done via 6 into 5, right? So this is 30. So there are 8 ways of winning X, right? And there are 6 ways of taking any 3X. So there are 6 ways in which you can actually put the 3X's, and there are 30 ways where the rest of the two zeros can fit in. So that counts to your 8 into 6 into 30 by the multiplication principle, and it is nothing but 40 ways. So there are only 1440 ways in which a TikTok game can end. If you remember our first lecture in the counting principle, we have also computed the number of moves where the chess game ends in 80 moves. It's such a humongous number. But here TikTok becomes boring because there are only 1440 ways in which it will end in fifth turn. I leave up to you as an exercise to find the number of ways in which the game will end sixth turn, seventh turn, eighth turn, and ninth turn. Right? Now let's look at one final example before we end this session. Right, find the number of, okay, we'll just copy and paste here so that you read it properly. Find the number of visually distinct way, please note, distinct. So we have this, we have to fill these distinct places, right, which are labeled 1 to n. So we have this number of places which is up to 2n, right? It is 1 2 3 4 5 6 and so forth till 2n, right? Ways of fitting n main and n women around a circular table with 2n seats such that the sexes alternate, right? When we say sexes alternate, the only way, let's start with let's make sure that first all the women sit in a particular order, right? So let's take an example where n is 5 so that you understand it better. So we take n is equal to 5. So we have 5 men, 5 women, right? And so we have 10 places. So we mark them as 1, 2, 3, 4, 5. 5, 6, 7, 8, 9, 10. So see, if we have to make the all women sit and the sexes needs to alternate, means if there is a man, then there should be a woman next to it. If there is a woman, there is a man next to it. Henceforth, if we start from this position, let's say women sits here, then women needs to sit here, women needs to sit here, women needs to sit here, and women needs to sit here, right? The second way which we can do is that women needs to sit here, the women needs to sit here, the women needs to sit here, and then women needs to sit here, right? So 5 women can be seated in such a position. There are only 2 ways of doing that. So what we will do is that first we will say there are 2 ways in which all women's, the 5 women's can sit, right? And now, so let's take an example of 2n. So there are 2 ways. Again similarly, and there are n women's, right? So this n women's can be arranged into these seats, right? Like these seats. We have to arrange because all the women's are different, right? So we can arrange all these n women's. In our case, it is 5, but we are now trying to solve the general case. So if there are n women's, so that can be arranged into factorial n ways. As we can know that you have to start with n, then n minus 1, and hence go till you go till 1, right? Now we are left with the n places, and there are n men's, and this n men's can be again arranged into factorial n ways. So we have factorial n ways where n women can be arranged. Now out of 2 n places are filled, so we are left with again with the n places and n men. That again can be done via n ways, the factorial n ways, right? So please note this again, that these all 3 are and. So there are 2 ways in which women can sit, and all the n women can be arranged into factorial n ways, and then all the n male members can be arranged into factorial n ways. So these are male, 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 and these 5 males can be arranged into 5 factorial 5. So all this will multiply into by the multiplication principle again will be this, and that is nothing but n square. So in our case, in our case, it will be nothing but there are 5 men and 5 women, so 5 factorial whole square. So that is 2 into 120 whole square. That is quite an easy one. So that will be, I'm just trying to compute it, right? So 144 and then you add 2 zeros, right? So that is 288. There are these many ways of making them sit into 5 men and 5 women into 10 places where men and women sit alternate to each other. So this ends up our basic problem set, and now we'll be in the next session we will be learning few more principles from counting principle, and then before deep diving into the final problem session. Thank you.